Hi, I'm Dr. Demena, and this time we're going to go over a major component of the circulatory system, blood. So the blood, which we refer to as the urethron, is described as a single system, and that's everything that's part of it. So things like mature blood cells, plasma, and then it also includes the different stages of development for each one of those cells. So they can be cells that are just now forming, newly forming in the red marrow, all the way to those individuals who are being culled out by the red blood cell graveyard, also known as the spleen. Now, depending on the needs of the individual, the size of the urethron or total blood volume changes. And it changes sometimes in the components of what the percentage of red blood cells is to white blood cells or plasma abundance. And so these can be adaptive changes, normal and healthy, which most of the time they are, but oftentimes being able to observe properly what the urethron is supposed to be, the constituents of the urethron are supposed to be, we can observe abnormalities and be able to predict pathological conditions. Now, there's also another component that we're going to go over in this series known as erythropoiesis, also referred to in larger sense as hematopoiesis. So hematopoiesis is hema meaning blood, and poiesis is referring to the genesis or the new formation, mitotic divisions producing new cells of that particular subtype, so hematopoiesis, blood cells. And in this case, we'll also specifically look at erythropoiesis quite a bit. Erythro means red, so we're talking about the red component or the red blood cells. So erythropoiesis is a highly controlled system. And many forms of what we can observe as hypoxia are what will initiate this response. Now, hypoxia can come in many different flavors from different origins, so we'll look at a few of those later on. So what does the blood do? It transports a lot of stuff. That's primary, its primary function is the liquid component of the connective tissue, right? So it transports primarily what we focus on are things like gas, nutrients, waste, also water, cell signaling, hormones. It also works to regulate and distribute different parts of these, what we would otherwise consider electrolyte levels in the body. Also kind of turning over the fluids, definitely getting that waste moved out and getting fresh, nutrient-rich, oxygen-rich blood to the cells. We'll also look at the process of blood clotting or hemostasis. And what blood clotting does is it stops the immediate loss of fluids when blood vessels are damaged. Also, we'll look at some parts of blood play specific and very highly evolved and developed roles in the defense against pathogens. And then finally, blood, being a little warmer than the rest of the body, assists in thermoregulation. Again, blood is a liquid connective tissue. And blood contains a couple of components, and we mix them up and define them in different ways. So we'll start first off, hold on, sip of coffee here. All right, contains cells, which we call the formed elements, and they're suspended in what we call the matrix, okay? And this is the blood plasma. So as you remember from other types of connective tissue, like cartilage, for example, there are cells, right, chondrocytes. Those are our formed elements of cartilage, and the matrix that they suspend is going to be a mixture of collagen and elastic. So that's their matrix, and a matrix is anything that the cells are suspended in, quite frankly. In this case, our formed elements, our blood cells, are suspended in our matrix, liquid, fluid, plasma. So the blood volume also is going to vary by age. Smaller size adult is around 4 liters, larger size adult is around 6 liters. And that also can change throughout even the course of a day in some cases, depending on how rigorous the exercises that certain individuals are undergoing, or blood loss due to trauma. Let's talk about formed elements. Okay, the first one we're going to talk about is the erythrocyte, right? The red cell, erythrocyte. We call these the red blood cells. Short form is RBCs. and they are by far the most numerous. Now over here on the other side of the screen, sorry, my laser pointer or my camera is not super operational today. And you'll see what we call a hematocrit. So this is a vial of blood that's been collected. The vial of blood that is red from top to bottom is not spun down. The second one, where there's this yellowish part on top and a little kind of pinkish gooey bit in the center like a belt, and then the bottom component, which is also very, very red, has been spun down using a centrifuge. The centrifuge allowed us to split heavier elements, in this case red blood cells, from lighter elements such as the blood plasma matrix. And then medium weight elements such as the white blood cells and platelets tend to collect in the center. The hematocrit is the proportions of each one of these plasma to white blood cells and platelets to red blood cell. So let's go back to erythrocytes. We know they're the most numerous, as you can see, using the hematocrit. So their main role is to bring oxygen to tissues and carbon dioxide to tissues. Now, it's not to say that they also don't bring nutrients and waste to and from as well, but oxygen is the most immediate, and CO2 is also the most immediate transfer that they do need to make. Red blood cells are produced without a nucleus, which is probably a safe bet. Any kind of cell that's going to migrate around your body doesn't need to have any kind of risk for, say, cancer. Cells with nucleus can usually, but not always, have the potential to divide. Without a nucleus, it provides more space for transporting oxygen, CO2, nutrients to and fro, and minimizes cancerous risks. The cytoplasm, or the jelly-like substance on the inside of the cells, is made of protein, hemoglobin, and electrolytes. They don't have a whole lot in the way of organized, what is the word I'm looking for? Organelles. Organized organelles, there it is. I gave myself my own clue. Right? Starting with the nucleus, but also they don't really need to produce a whole lot. Their job is to simply be essentially zombies that carry around things like blood, carbon dioxide, nutrients, electrolytes, all kinds of good stuff around the body. Oh, and of course take away the waste. How long do they live? A couple months, maybe half a year at most. Not too long. Generally, they're pretty small. They're what looks like, because they have no nucleus and not much in the way of organelles, is a biconcave disc. And that's actually going to provide a lot of surface area for that oxygen CO2 transfer. So it turned out to be a double win. Anyways, we'll look at that in a minute. So back to other cellular components. So leukocytes, white blood cells, these are used as body protectors. They do things like solicit immune responses, swallow up rogue bacteria and fungi that somehow enter the body, and also work to protect the body from future invasions. And then finally, we have these teeny tiny little platelets, also known as thrombocytes. And these control and work integrally in the process of hemostasis, right? So the formation of a blood clot. So these platelets themselves are not cells truly either, very similar to the red blood cells. Whereas red blood cells are originally cells with a nucleus, which they lose before they mature. A platelet's a little different. It's a part of, as you can see, the big one down here, a monocyte in purple. This monocyte has all of these long little arms, and it branches and breaks off tiny little pieces of that. Those pieces form the platelets. Let's go a little bit deeper into the white blood cell components. Now, believe it or not, there's more that we'll talk about regarding this in a bit, but I wanted you to get a basic idea of who's who and who's there. So the first one we have listed is a basophil. Now, basophil, if you look closely at the nucleus, has tons of little super dark purple spots all over it. So those little spots we refer to as granules because they look like grains of sand, for example. So there's granulocytic white blood cells, cells that have those little granules, and then there's, if you look down below it, agranulocytes, or cells without little granules all over their cytoplasm. So in this case, Our basophil here is our granulocyte. And the nucleus itself, as though you can't really see it because of all the granulocytes, is lobed, which means it kind of doesn't have that perfect round shape, but instead has big districts to it. It lasts anywhere from a couple days to a couple hours, depending. Its primary job is inflammatory. It works to do things like release histamine and dilate blood vessels so that more blood components can be shipped out to areas of the body that are undergoing some type of attack, right? They sound the alarm and pave the way for fast delivery of blood components. The agranulocytes are a little different. They come in a couple flavors. First are what we call the lymphocytes. Now, these are the white blood cells that basically went to school in the lymphatic system. And they do a couple of things. There's a couple of categories that we'll talk about in a bit. But what they do is they mount a complex immune response by the cell, and they use these particular proteins called antibodies. These cells last anywhere from a couple of days or weeks to years, actually some of them even decades, as we've seen with the efficacy of certain types of vaccines. These are the ones, the vaccines. They work with these lymphocytes to train them how to recognize a disease that an individual could perhaps need to mount a really swift immune response to. Moving forward, these are monocytes. This large, it looks like it has a big giant U-shaped nucleus, and it does. These are honkin' big cells. They last for a couple days to a couple months. And what do? They go up and they eat rogue pieces of cells. They have been known to eat cancer cells inside of an individual's body. Mainly what we look at them as are going towards pathogens. These are those white blood cells that engulf or endocytose things like rogue bacteria or fungi that have invaded the body. And then down here at the bottom are thrombocytes, our teeny tiny platelets. So these are discoid cytoplasmic fragments. So it means they're not true cells. They don't have any nucleus. They're basically broken off from our megakaryocytes, very big cells. They last for a couple of days. And what they do is they work to seal small tears in blood vessels. So they will pretty much drift around nice and smooth and shiny, but when they come into contact with certain types of proteins, all of a sudden, boom, their spikes come out and they get very, very sticky. And so when they stick together and clump, they can help form a clot faster and thusly start beginning to facilitate the process of hemostasis or blood clotting. Blood plasma. Blood plasma is the fluid part or the matrix part of blood. It's not alive. It's secreted. It's mostly water also, up to 92%. Other types of things that are in there, mainly things like solubilized gases, a couple of electrolytes, definitely some protein in there. We'll talk about the different kinds later on. Also, some hormones and cell-cell signaling molecules are also dissolved within the blood plasma. So, right, the other thing about blood plasma you need to know is it has to be kind of a high volume because it has a lot to ship around. But it's not as high as many people originally assume. It's only about 55% of the total volume of blood, meaning blood itself is very viscous. Let's talk about what serum is. So serum is different from taking a whole blood draw. So there's whole blood, which contains things like fibrinogen, right? The precursor molecule to fibrin. Fibrin works to make blood clots. It's a fiber, essentially, that has to be cleaved, and it's used during hemostasis to tie down that clot. However, if you take a sample of whole blood and you leave in these clotting components, what happens is the blood starts to clot in the tube, so it has to be removed. So blood that has, especially blood plasma, is the clotting proteins taken out like fibrinogen and a few others, is referred to as serum, and it remains liquid. It doesn't turn into kind of a jelly-like solid. So 90% or more of the blood plasma proteins are synthesized by the liver. Liver health is crucial to healthy blood. The erythron absolutely depends on good liver practices. Liver disorders can be monitored, but predictably can also result in altered blood composition and function. What types of proteins are in the plasma? Well, here's the three main kinds. The last one, fibrinogen, we talked about a little bit. It works in blood clotting, and it is the precursor molecule to forming those strands of fibrin, which help basically duct tape down the blood clot. Very strong, very, very strong. It rules out at about 4% of all the proteins. However, the lion's share is split between the albumins and the globulins. So the albumins, there's a lot of it, up to 60% or more. What do? They work to maintain osmotic pressure of plasma. They also help keep it viscous, and they help keep the components dissolved within it. Albumin is great for keeping even distribution of the liquid components of blood. Globulins are kind of like how their name sounds. They make globs of protein. Usually they have more than one subunit, or they're anticipated to bind to something else, or at least just attached. Many of them have very specific jobs, such as antibodies, immunoglobulins, and transport proteins that carry things to and fro throughout the body and/or cells. Blood's warm. It's a little bit above regular body temperature. So blood is also, as we've been talking about, full of all kinds of dissolved components, and the liquid component is really only about 55%. So it means the blood is viscous, meaning it's literally thicker than water. So it's sometimes also referred to as being sticky, heavy, right? Stuff like that. And it's because of all of the different proteins and cell types that are within it. Also, blood is a little bit alkaline, so slightly basic, and it sits between the range of 7.35 to 7.45. 7.45. So those are some of the blood basics. I hope that helped you get oriented. Now go ahead and watch a few more of our upcoming videos and learn a little bit more about this wonderful organ, blood.